Hello everyone, and welcome to this EMTP webinar from the series Products. My name is Henry, and today I have the pleasure to present you all the new features and examples of the last release of EMTP, the 3.1. Again, this time, an amazing work has been done by our development team to make the software even more user-friendly and powerful. And so we are very proud to demonstrate all the new capabilities today. So let's start from the beginning. How to install the software. We have some new features in here. So at the beginning, it's the same process as before. You go on our website, emtp.com, and you access to the support section, download. Okay, so here you will have to register with the email address and the password that has been provided to you the first time you requested a license. Okay, once that's done, we still have the same link as before to download all the package and scope view. However, one thing new now, you also have to download the Matlab compiler runtime, the 60-bit version. Basically, we upgraded MPLOT, which is the tool to look at the results of the time domain simulation. And before it was 32 bits, now it's 64-bit. So that's the reason why we have to install this new compiler. The advantage now is you can run very long simulation and look at the results even if the memory usage is it's huge without any problem. So it's a very big advantage. Maybe some of you experienced some trouble in the past with the memory of MPLOT. So to install it, it's very easy. You just have to follow the link and basically install the version Air 2014A, the 64-bit for Windows. Okay, once that's done, you can install EMTP with the zip file provided once you download it on the website. Okay, so after that, once everything is installed, the procedure is almost the same. So you click on, you open EMTP. If it is the first time you open this version and you don't have a license yet, you will have a Windows that will pop up and eventually bring you to the EMTP activation utility. If this Windows doesn't pop up, to access to it, you go to the section File, Help and Support, EMTP Activation Utility. So this is a new tool actually that centralize and help you to manage all the licenses you have. Okay, so when you open it here, you can see all the licenses present on your computer and for what version. You can access to the details of this license. Okay, and also you can request a new license or import a license file. So you will request a new license. For example, if you're a new user, you just had a trial license, so you received an email with a lot of information. So that's where you have to input all this information. Okay, so you click on the request license file and you enter your last name, your first name, email, the name of your company, the unit number, the access code. And here you have to select your host ID. So be careful not to select any kinds of virtual network address, but to choose the actual MAC address of your computer, which is in the end a physical address. And then you can click on automatic activation. As soon as you do that, automatically the license file will be generated and placed in the good location of your computer. It's always also possible to do that by email. If you click on that, you will write an email with all the required information that will be sent to us, and we will send you your license file by email. So in this case, in case you receive the license file by email, usually it's a text file. What you have to do is simply to first save the license file sent by email to your computer, and then to click on import the license file. So see here, it's an example. You select one of them, okay, and then you will have the message that the license file have been created. Okay, here it was one of them. So yeah, it's pretty easy. At any time of the process, if you are a bit lost, you don't know what to do, you have access here to the help. Okay, so the help, it's a PDF file which guide you through all the steps. So it's very well done. It makes everything more easy than before, and everything is more automatic. Yeah, so that's the first big news for this new version, the License Utility Manager. So also, before, now we still have the same graphical user interface as the version 3. The version 3 was the first one to have the new GUI. And so, of course, it was, the first time it's always more difficult, so it was a bit long to open the software. Sometimes maybe you had experienced some approximation in the display, in the display. So now, in this new version 3.1, all these issues have been fixed. So it's very fast and very robust. It's very pleasant actually to use this version. So maybe we can have a look at some example to see the graphical user interface. We have a long list of new examples. There is one I really wanted to see with you because it's a very impressive one. It's actually a large grid. So it's in the category large grid. It's the benchmark T2 Win and HVDC. Okay, so it's a pretty big case. I wanted to show you this case because more than ever it shows the crazy capability that a software like EMTP RV is reaching nowadays. In the past, transient software was a synonym of doing small simulation of a network with 4 buses maximum and a quick simulation. But look at where we are nowadays. Look at that. If we look at the property of this design, see that it's almost 22,000 devices in here. More than 3,000 signals. It's a huge case. We can go through it a little bit. Okay, so we have here a lot of machines, right? So we can go inside there. It's four machines in parallel with the power constraints. Okay, for the load flow. Here it's a PV constraint. Here all the governor that is modeled, the transformer with saturation and non-ideal units. Okay, then you can see here we have an onshore wind park. Okay, so we can see what happened inside. It's a different wind park in here. So it's a very detailed. So you can see the number of lines, the number of machines. So here, anytime it's a sub-circuit with a lot of different units inside. And here, look at it. It's an offshore wind park linked with an HVDC link, MMC or 400 level. So that's something huge. I don't know if some of you are familiar with MMC technology. It's a crazy challenge to model such a thing in a software like EMTP, because like an HVDC with 400 level like that, you get more than 2,000 IGBTs inside. You have all the control, the protection. It's extremely challenging, but very, very precise to do such a thing in a transient software. Okay, so we can see here, here all the control, the initialization for the load flow, and in the end the IGBTs. And then here you have all the wind parks. Okay, so for what's the goal? You will tell me what's the goal of simulating such a huge system on the transient software. Well, the first thing is now you have access to this level of precision for a long simulation. So why won't you use it? Why would you keep using approximation, only work with the positive sequence? Hey, you are in the phase domain. You have access to a very high precision, and it's fast. So that's, for me, that's a good reason to use a transient software to do that. Here also, you know, the goal of such a simulation is actually to make sure that the control of all the different machines, of the different wind turbine, HVDC, how they all react together after an event. Okay, so that's actually the real goal of doing that in a transient software, because the model of wind turbine and of HVDC of a transient software are way more precise as every other kind of stability package. Okay, so here what happened, we have a fault on the network, and we want to study the interaction of all these control together. So actually for this particular case, we use average value model for the wind turbine and HVDC. So it make it possible to run the case faster. Okay, so let's run this simulation together. Okay, so like always, we start with the load flow. Okay, the load flow in that case will be used to initialize the system. So usually the load flow simulation is very fast. Okay, here we go. And so now let's do the time domain simulation. So we will simulate 3 seconds with a time step of 50 microseconds, which is, I mean, fairly big for the study of renewable energy. But since we are using average value model, it's completely fine to use such a time step. Okay, so we can, so here we have the fault that occurs at 0.5 seconds. So let's run the case and we can look together what happened. Okay, so this case will take a few minutes to run the whole thing. It's 3 seconds, it's pretty long. Okay, so let's wait together the simulation starts. Okay, so here we go. And so we can display the result while the simulation is running. Okay, that's not new, but we can do it. So for example, the voltage where the fault is, maybe the current as well. Okay, we can put all that on page 1, and let's display the power of the different components. Okay, so for that I will use the filter at a different location. For example, in the HVDC, we have some power scope like that. So I can use the filter of scope view to find them directly. So I use the filter, so I check it here. And so usually the way they are written, it's P at control. So we can see them all here. So that's the power transmitted by the MMC. Okay, and we can put the power generated by some of the wind turbine and see if everything converges after the fault, during the fault first, and once the fault is clear. Okay, so we can display all that during the simulation. Actually, we can make the plot refresh during the simulation. We just have to here put several acquisition. Okay, and so that it evolves during the simulation. It's dynamic. I mean, it's a nice feature. It's not new, but it's still pretty nice. Okay, so here is the power, and here is the voltage at the fault location and the current. Okay, so we know the fault occurs at 1 second. So here what we can see is the power. So for the one of you who are familiar with the wind turbine in Emt-P, the way we initialize them is that we link them with a power constraint. Okay, and so basically first we do the load flow. Thanks to the load flow constraint, we find the voltage at the terminal of the wind park, and then we hold this voltage for 0.2 seconds, the time the actual wind turbine, the IGBTs, etc. initialize. And so then we connect them, and we can experience some of a little transient like that In that case, it's actually a pretty big one. It's really the limit of acceptable, but most of the time it's even smaller. And after that, after 0.5 seconds, you are ready to go to run an event. So here, to be sure, we put the fault at 1 second, but we could have put it before. Okay, so now the fault is happening. So we can see here the current through the fault. Okay, so with the DC component, like always, and so then we're going to clear the fault after about 0.1 second. Okay, so it's coming soon. And so we can see here how all the controller of each wind turbine react. Okay, so they adapt themselves. Okay, so the fault is not cleared yet. Okay, so now it is. Okay, we can see we don't have any current anymore. We actually opened the line close to the fault. Okay, so we opened the line here and here. Okay, so as you can see, it's pretty fast. We are already at half of the simulation. It's pretty fast for transient software to do something, a case as big as that. Again, remember that here we have almost 23,000 of devices. Okay, so it shows again where we are nowadays with a transient software like EMTP, and more than ever, it demonstrates that EMTP is leader in large grid, in the simulation in the transient simulation, of large grids. Okay, so let's keep going on the new feature of the software. Actually, a new one which will be very helpful for all the new users. It's the Help Center. So the Help Center is a new tool. You can access to it if you go to File, Help and Support, and you can here click on Open EMTP Help Center. So basically, it's a new tool that centralizes all the help documents, the devices, the device documentation, and all the resources in one place. Okay, so for example, here, if you click there, you can see you have, if you are new to EMTP, a quick overview of the software. Okay, so it's a small document of about 30 pages that explain all the first steps to know how to learn EMTP. Then some video tutorial or some FAQ on the web. Then to keep learning how to use EMTP, you have the Learning Center, where you have access to some user manual, the help for all the devices that are in the library, the EMTP simulation option. You also have a link to access directly to our YouTube channel, where we usually put all our webinar, like the one we're doing right now, will be on YouTube eventually, but also the webinar study from A to Z, where we learn, we speak about very specific topics, technical topics, and you have a link here to access to send a request to the support. Okay, here you have some documentation on scripting. Okay, as you may know, EMTP is a very convenient tool, very flexible and customizable. So you can write script to do basically whatever you want. So if you need information about that, you can click in here. Also, here you have a link to learn how to build a new model using a DLL. So it's where you can write your code and create a device out of that follow the code and then integrate this device inside a network in EMTP. Then here you have a link to access to some of the online EMTP community. So you have the Exchange platform, okay, which is where you have a lot of things. Okay, it's where every user can exchange some of their network, new devices, publications. Okay, so it's an exchange platform, very convenient. Sometimes sometimes you have to do some work, and maybe you can have a look there, and the work has been done by someone else. So let's take it. Okay, so here you have again some technical presentation from the web, the forum, and the LinkedIn of EMTP. Okay, and so finally here you have everything about the new tool, the EMTP activation utility. You have the page here to download the software and the license agreement. Okay, so again, it's a very convenient tool. Everything is centralized in here. Actually, also you have here a search bar. So, for example, if you want any information about, I don't know, about something like a transformer, you can just write it, and then you have all the links in the result. So you can see here. Maybe I should write a little bit more. Okay, transformer. So you can see here all the help document about the different model of transformer we have, the three phase nameplate input, the three winding transformer, the hysteresis, etc. So everything is centralized in here, and I'm sure it will be very helpful for all the one of you that are new users. Okay, so another thing is now we have a solution. Maybe in the past, some of you had problem. The people who are using high resolution screen, you had some problem in the display. For example, here the tab were not displaying properly. You couldn't see all the information inside in one Windows. So if you still have this problem, now we have a solution for that. So again, it happened for the people if you use a font size selection in Windows that is more than 100%, or if your data input web page are not showing all the parts. So then what you have to do, it's pretty easy. You just have to go to EMTP, click on New, and open a JavaScript. Okay, and so then you have to write the following command. Let me find this command. Okay, 1 second, please. Here it is. Oh, sorry about that. Here. Yeah, sorry about that. So here's the command you have to write. I apologize for that. Okay, so here I will copy and paste it. So you just have to copy and paste that here. Write state string web resolution square 1. Okay, and same thing here for with high, and then you click on run script, and automatically you will not have any problem anymore. So one more time, it's you can experience such problem if your font size selection in Windows is more than 100%, or if the data input web page are not showing all parts. Then you can write this script, and it will solve all your problem. Again, you can contact the support if you need help on that. Okay, so quickly, so now to sum up with all the new feature of the software. Okay, so actually there is one I forgot, which is actually pretty helpful, and I'm sure a lot of you will like it. So now all the tab can float. Okay, and so you can organize them as you want. Okay, so let's make an example. Okay, so for example, yeah, if I open this this subcircuit, now I can choose to if I click here on float, to basically remove it and to put it somewhere else. Okay, so it's pretty convenient. Also, if you open let's say a lot of them. Okay, if you go into detail, you can go from one tab to another by clicking on the shortcut Control Tab. Okay, and you can go quickly like that from one to another. Also, you can organize inside your EMTP. You can do horizontal or vertical groups. Okay, and put it like that. And so then you have a new tab for the a new doc. Sorry, for all the tab. Okay, so it's very convenient actually, and I'm sure a lot of you will like this new feature. Especially the one of you who works with 2-screen, I really like doing that with 2-screen. Okay, so we talked about the new help center, the license activation. So then we have also some a new function for the symbol editor. Okay, so before, if I go, for example, to edit the symbol of this transformer. Okay, so before you could choose between a power pin input and output, and basically the pin was considering what you were connecting to it. Automatically it was turning into a 1-phase or a 3-phase. Okay, but I'm sure some of you experience this problem when you try to connect a 3-phase signal to a 1-phase power pin, and you have an error message, and the pin switch into a 3-phase. That can be annoying. So now you can force your selection and force the pin to be only 3-phase, in which case the connection with a 1-phase will be impossible. Okay, so that's something new. Always more improvement in the documentation. For example, the DLL documentation have been completely rewritten, which make it very easy now. Okay, so we have now the new capabilities for the high resolution screen, and also the new MPLOT. Okay, so I can quickly show you the new MPLOT. Okay, so the same as before. To access to it, you can go to the tab Simulate, click on View Scopes with MPLOT, or you can right-click and click on MPLOT here. Or finally, the last option is to go to bring the option device MPLOT. Okay, and to double-click on it. Okay, so the new MPLOT now 64 bits. Is so way more powerful. You will not experience as much memory problem as before. And also now there is a filter in MPLOT. So when you have a lot of signal like that, you can basically use the filter directly, like we do in scope view. Okay. So here I'm looking for a signal that doesn't exist. So after, for all the displays, the exact same thing as before. Okay, you click on plot and everything gets displayed. Okay, so what else do we have new in here? So yeah, the last thing now new in this version, it's already a lot for just a release, but I told you we worked a lot this time again. So yeah, a new collection of example. So a lot of new IEEE case, the 39 test case. Okay, so we can have a look at them quickly. So we have one with in here. So one with a wind offshore. Okay, we have another one to study for particular study of GMD, which is pretty interesting. Okay, I will open it as well. Those are very big cases. So it's a 39 bus, but there are wind park and inside, so it makes the number of devices very big, and it takes some time to open, of course, but it won't be that long. There we go. Okay, yeah, it was a bit long because see, this one is also a fairly big test, fairly big design, 22,000 devices again. So what do we have here? It's again HVDC link, okay, with a lot of not an HVDC link, but a lot of wind turbine. Okay, and here is the HVDC link. So it's almost as big of a design as the one before, actually. Okay. what else? So I talked about the GMD one. So also for this particular type of study, now you have an example available. So it's convenient to as a starting point to see how to do such a study. Okay, so see, you can see here all the GMD induction field voltage vector. Okay, so you can set that here and then add the DC component of the voltage all around your network. Okay, and study like that this case. So here we are talking about a very long case, right? So the simulation time is the simulation time is very long, 170 second. Okay, but you get again very precise for those kind of simulation. I mean, there is no other way, there is no other software that can do stuff like that, only transient software. Okay, so let's close a little bit this design. So we also have a new cable case. Okay, we always have a big demand for some cable example. Actually, at the moment, we are working on a new database for cable. So in the future release, you will have a lot of database for cable lines, etc. So here, if you go in the cable, line cables, okay, you have see here all the new cable case. Okay, so here's one. So it's a comparison between a constant parameter model of cable and a wideband. Okay, you have some energization case with arrestor. So it's kind of TRV study. We have a lot of new example with TRV. Okay, here you have one short line faults on TRV. Okay, it explains quickly how to do a TRV study. We did actually a webinar on that is available on YouTube. So it's one more resource for the study of TRV to learn how to do such studies. Okay, we have also this case, which is the steady state coupling. Okay, so here we study the coupling between 3 parallel transmission lines. Okay, but only with the steady state capabilities of EMTP. Okay, so it's a pretty interesting case. You can also, of course, run the time domain simulation. But in that particular case, which is a real case, by the way, the engineer, their goal was to study only in steady state the coupling between the lines. So we have also a new example, basic example actually, but that a lot of users were asking for about power electronics. Okay, so let's look at them here. So we have a buck boost. Okay, so we can have a look at that. So very easy example. Actually, I think we already had this one before. Sorry about that. But we have now the 3-phase inverter and 3-phase rectifier as an example. Okay, so if you need to use them, you can directly copy and paste them from this example. Everything is built inside. See, so it's very clean. With with the model of a good model of IGBT. As you may know, a big difference of EMTP, a big asset of EMTP for the power electronics is the model of IGBT and the way we solve the nonlinearity, right? Because we don't use only on-off diode, right? We use a real diode with the good characteristic, and we do iteration. Okay, to know where we are on the characteristic of the diode. So I mean, it's more precise than that any other tool to study the power electronics. You basically don't do any approximation, and you're allowed to put bigger time step because since we do the iteration within a time step, we can have a bigger time step without making too many mistakes. Okay, so what else in the new examples? We have a new PV example now. So it's we improved the previous version of our photovoltaic model. we saw together the large grid already, which is very impressive. And also we have an example on a line impedance modulator. Okay, so pretty interesting as well. In here. Here we go. So here that's the new the example about that. Okay, so I am done to present all the new feature and example of EMTP. Okay, so again, if you have any question about that, about anything we saw today, please don't hesitate to contact us. Okay, all our information to contact us are actually online. Okay, so if you have any question on some sort on the new version of EMTP, please don't hesitate to contact us. Okay, you can send us a message at sale@emtp.com, or if it's a technical question at support@emtp.com. Also, we're gonna stay connected for 15-20 minutes to answer all the questions, so please don't hesitate. I really hope you enjoyed and you got excited to use this new version of EMTP. Thank you very much for attending this webinar. It will be available on YouTube very shortly, probably within 24 hours. If you need to see something again, one step of this presentation. So, yep, thank you very much, and have a wonderful day. Bye-bye.